Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about operational amplifier. I'll explain you how to draw comparator circuit using three identical resistors and a thermistor. Very important concept about operational amplifier. For question 7 part A, simply we need to draw circuit on figure 7.1. We need to use three identical resistors and resistance of each resistor is 1000 ohms. We also need to use one negative temperature coefficient thermistor. Negative temperature coefficient thermistor, often we call this one NTC thermistor. It simply means that the resistance of this thermistor depends on temperature. When the temperature is higher, resistance of this resistor will be lower, and when temperature is low, resistance of this thermistor will be higher. So this is very important point we need to understand about NTC thermistor. This is a special kind of resistor and its resistance depends on temperature. Now the next thing question is telling us that we need to design a circuit. That condition is that at low temperature output V out means the output has to be negative, and when temperature is higher output has to be positive. Simply we can write down here, when temperature is low V out has to be negative. When temperature is low, resistance of thermistor will be higher. The second condition is that when temperature is higher, V out has to be positive. And when temperature is higher, resistance of thermistor will be lower. Let me explain to you a little bit about potential divider. As you can see here, we have potential divider circuit here, and you can see there are two resistors and they are connected in series. Let's say the resistance of this resistor is equal to 4 ohms. Let's say this is 4 ohms, and resistance of this resistor, let's say this is 2 ohms. If we connect our voltmeter across resistor 1, you will simply say the reading on this voltmeter will be equal to 4 volts, because the resistance of this one is double than resistance of second resistor. If we connect our voltmeter across this second resistor, voltmeter reading will be 2 volts. Now the question is that if I ask you what is value of potential at this point, you will simply say this is 6 volt. And if I ask you what is value of potential at this point, you will simply say this is 0 volt. Then the question is that what is value of potential at this point? Now you need to understand is that at this side the potential is 0 and the potential difference is 2 volt. So the potential at this point simply will be equal to 2 volts. And this understanding is very important and we need this one to draw the circuit. If this point is very clear to you, drawing this circuit is not difficult. So let me show you how to draw this circuit. Let's try to understand a little bit more about potential divider, and then I will go to this circuit and I will explain you. As you can see here, in this case, when R1, this is greater than R2, value at this point means I can say this potential V1, this one is smaller, this value is low. And when R1 is smaller than R2, you will see V1 means I'm saying this potential is V1. This potential will be higher. So simply you can understand like this. Let's say R1, I replace this one. The resistance of this one, let's say, is 2 ohms now, and resistance of this resistor, let's say, is 4 ohms. Now simply you will say the potential at this point, that will be equal to 4 volts. Now this is very important point. Simply we will use this one and we will check the circuit. Is this circuit is correct or is this circuit is not correct? Now for first condition, when temperature is low, V out has to be negative and resistance will be higher. So in this case simply we can say this resistance will be higher. So this resistance will be higher when temperature is low. So when this resistance is higher, so the potential at this point, potential will be lower. It simply means that V plus will be lower than V negative. In this case, V out will be negative. So this one is correct. Let's check the second condition now. When the temperature is higher, resistance of thermistor will be lower. When temperature is higher, resistance of thermistor will be lower. When resistance of thermistor is lower, as you can see, when R1 is lower, R1 is smaller, then R2, V1 has to be greater. The value of potential at this point, that will be greater. So it means that V plus will be greater than V negative. And in this case, V out will be positive. So our circuit is correct. This is how you need to draw the circuit. I hope now you are very clear about this. Part B is simply asking us, we need to state a suitable value for the thermistor resistance when the thermistor is at low temperature and V out is negative. So the first thing we need to understand is that when V out will be negative. V out will be negative when the potential at A is greater than potential at B. So we can simply say that when VA is greater than VB, V out will be negative. So simply we can say V out will be negative. V out will be negative when VA is greater than VB. Let's say the resistance of this thermistor is R. As you know, all these resistors are identical resistors, and resistance of each resistor is equal to 1000 ohms. And this is given in the question. Let's say the resistance of this thermistor is RT. Potential at this point will be lower when RT is greater than resistance of R, or we can say when the resistance is greater than 1000. We can also write down when RT is greater than 1000 ohms, V out will be negative. For the second part, question is asking us at higher temperature when V out is positive, we need to suggest a suitable value for the thermistor. So we can write down here now when V out will be positive. V out will be positive VB when VB is greater than VA. In this case, V out will be positive. So this is the first thing you need to understand. V out will be positive when potential at this point means that this terminal is greater than potential at this terminal. So when this is possible when resistance of thermistor is less than resistance of fixed resistor R. Or we can simply say when RT is less than 1000 ohms. It has to be less than 1000 ohms. This is how you can simply write down your answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about Electronics chapter from Cambridge A2 Physics. In this lesson, I'll explain you how to draw circuits for the output devices such as light-emitting diodes, or simply we can call them LEDs, and relay with the help of past paper questions. For this question, it is given to us that the output potential of an operational amplifier is monitored using an output device. An output potential can be positive 5 volts or it can be negative 5 volts. Part A is simply asking us on figure 10.1. So here is figure 10.1. We need to draw a circuit for the output device that consists of two light emitting diodes B and J. Diode B alone. Very important thing we need to understand, alone means only diode B has to emit light when V out is positive 5 volts, and diode G alone means only has to emit light when V out is negative 5 volts. So this is what is given to us. In order to answer this question, we simply need to understand what is meant by polarity of LED. Polarity simply means that if you look at this typical symbol of LED, you can see one side is marked as positive, or you can say this is anode side, and other side is marked as negative, or you can say this is cathode side. So it simply means the positive side has to be connected with positive terminal and negative side has to be connected with negative terminal of power supply. So in this case, this LED will be working. But if we connect in a wrong way, means we connect the positive end of this LED with negative terminal of power supply and the positive terminal of power supply with negative end of LED. In this case, simply this will not work. So this is main concept we need to understand to answer this question. Second thing, it is also very useful to understand what is the maximum value of current that can pass through LED, that is 20 milliamps, and this is a typical value. Also, we need to understand what is the maximum value of potential difference that we can apply across LED without damaging LED, and that typical value is 5 volts. Now if we have understanding of polarity of LED, then this question is just very simple. It's just based on polarity of LED. If we look at real image of LED, we can also find out which side has to be connected with positive terminal and which side has to be connected with negative terminal. If you look at this leg of LED, you can see this one is longer one and this is anode side. It has to be connected with positive terminal of power supply, and the other leg you can see this is shorter one and this is cathode side. This has to be connected with negative terminal of power supply. As you can see here now, I have already drawn this circuit, so let me explain to you so you can have better understanding about this circuit. For diode B, it was given to us that diode B has to emit light when V out is positive 5 volts. So it simply means that when this V out is positive, you can simply see that the positive end of LED is connected with V out positive. So this one will be conducting, means this LED will be on. And it also given to us that alone means only B has to be on when V out is positive, and this is true because this end of LED G is negative and this one will not be conducting. So this is true. Now let's move on to second one. Diode G alone has to emit light when V out is negative 5 volts. So you can see now the negative, when the output, this output is negative, means when this is negative, you can see now, so negative is connected with negative, so LED G will be conducting, means this one will be on. But as this is negative now, it is connected with positive end of LED, so LED B will not be conducting, means this one will be off. So this is how we can answer part A. Maybe you are a little bit curious about this resistor. Why do we need to connect this resistor in series with LED? This resistor, actually we call this is protective resistor. The purpose of this resistor is simply to protect LED, because the maximum current that can pass through LED, means the typical value of maximum current, that is 20 milliamps. If current exceed than 20 milliamps, LED will be damage. So in order to limit current, we have to connect protective resistor in series with LED. So simply its purpose is to protect LED. For part B on figure 10.2, we need to draw a circuit of the output device that consists of a relay and a diode such that a high power lamp is switched on only when V out is negative 5 volts. It simply means that when this V out is negative, this high power lamp, this has to be on. And when this V out, this is positive, this lamp has to be off. So this is given to us, means this is condition, and based on this condition we need to draw circuit. And in circuit simply we need to draw a relay and a diode. As you can see here, I have already drawn the circuit, and in this circuit you can simply see here we have connected one diode here and we have connected relay at this point. We have another diode that is connected here, and this diode simply we call this one is protective diode. The purpose of this diode is to protect op-amp from back EMF. So we can simply write down to protect op-amp from back EMF. Now when this V out, this is negative, current will flow in this direction. When current will flow through this solenoid, this will be magnetized. When this will be magnetized, it simply means that this will act just like a magnet, and this switch will be closed. And when this switch will be closed, means this switch will be attracted and switch will be closed. When switch will be closed, circuit will be on. When this circuit will be on, this high power lamp also will be on. One thing more you need to understand is that these two diodes, they always have to be connected in opposite directions. Opposite direction simply means that when this diode is pointing down, this one has to be pointing up, and if this one is pointing down, this one has to be pointing up. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about operational amplifier. And in this lesson, I'll explain you some important concepts about this topic with the help of some typical past paper questions. For this question, a typical operational amplifier circuit is given to us. As you can see, it is shown in figure 10.1. Part A1 is simply asking us, we need to show that potential at the inverting input of op-amp is 1.0 volt. So this input is called inverting input, this negative one. So this is called inverting input. Simply we can label this one, this is inverting input, and this input is non-inverting input. And question is simply asking us, we need to find the potential at this point. Let's say this potential is V0 and we need to find the value of this V0. And also if we look at this end of resistor, as this is connected with ground, so the potential here is equal to 0 volt and potential here is equal to 4.5 volts. Now this question we can simply answer here, but let me redraw the circuit so you can see a clear picture of this circuit. Then it will be quite easy for you to understand what is happening. Now as you can see here, there are two resistors. One resistor is here, so this resistor is 4.2 kilo ohms and this resistor is 1.2 kilo ohms, as you can see here. Now we can also imagine that there is one power supply that is connected here. So this is our power supply, this is 4.5 volts. The EMF of this power supply is 4.5 volts. Now question is simply asking us, we need to find the value of V0. Now you see at this end the potential is equal to 0 volt. So we can simply say that the V0 is simply equal to potential difference across 1.2 kilo ohms resistor, or we can simply say that if we connect our voltmeter here across 1.2 kilo ohm resistor, the reading on this one, that will be equal to V0, and that is equal to the potential at inverting input. And if we need to find out the potential difference across this resistor, simply we can use potential divider formula and we can find out. So simply in this case V0 will be equal to 1.2 divided by 1.2 means divided by the total resistance. So total resistance is here, and we need to multiply by potential difference across power supply. In this case the potential difference across power supply, that is equal to 4.5 volts, and our final answer will be 1.0 volt. And this is the value of potential at inverting input. So this is how we can answer this question. For second part, simply we need to explain why the potential difference across resistor R is 5 volt when V in is greater than 1.0 and why it is 0 when V in is less than 1.0. So let's see where our resistor is connected. First of all, you need to understand this circuit. If you're very clear about this circuit, this question will be quite straightforward one. You can see our resistor is connected here, and here is the V out, mean this is the potential difference across this resistor. When V in is greater than 1.0 volt, the value of this V out, this is equal to plus 5 volts, and second, when V in is less than 1.0 volt, the value of this V out, this is equal to 0 volt. Now this is simply we need to explain why it is like this. So V in is here, and this is given to non-inverting terminal, and inverting terminal, this potential is fixed. This is 1 volt. Now the first thing you need to understand is that if we look at first case, when V in is greater than 1.0 volt, it simply means that when non-inverting terminal potential and non-inverting terminal, this is greater than inverting terminal. So what will be the output? So output in this case V out, this will be positive. So this simply you can understand the V out, this is equal to the gain, this is gain, time this is V plus minus V minus. I mean this is potential at non-inverting input, and this is the potential at inverting input. When V plus is greater than V minus, our output, this will be positive. This is one case, and the second case we can write here, when V minus is greater than V plus, means when the potential at inverting input is greater than non-inverting, in that case V out will be minus. So these are the key points we need to understand. And also we need to understand the gain of ideal op amp, this is infinite. It simply means our op amp will be saturated. It simply means that V out will be equal to V of power supply. I will say that will be equal to V of power supply. So in this case, as you can see, the power supply is 5 volt and minus 5 volt. So it will be 5 volt or it will be minus 5 volts. So these are the main concepts we need to understand. If we understand these concepts, then we simply need to understand how to write a proper answer. Now let's try to write a proper answer now. As you can see here, I have already written these answers for you. So I will simply explain a little bit so you can understand how to write a proper answer. As you can see, first of all, I have written V in is greater than 1.0. Output of op amp is positive and saturated. Diode. The second thing you need to understand is this diode. As when V out is positive, so this is in forward biased. So the potential difference across resistor R means across this one, that is equal to plus 5 volt. And when V in is less than 1.0, so it simply means that output of op amp is negative, and again our op amp is saturated. But if you look at this diode, now current will try to flow this way, but current cannot flow because this diode is in reverse biased. So as no current is passing through this resistor, so this Vout simply will be equal to 0 volt. For part B, the variation with time of the input voltage is given. As you can see, it is given in this figure 10.2. Or we can simply say this is voltage is given on y-axis and time is given on x-axis. And this is also given to you. This is plus 1 volt. This is just a reference. And here is V in. Means the variation with V in with time is given to us. And question is simply asking us on figure 10.2, we need to draw the variation with time t of the output potential Vout. Actually, this output potential is simply the potential difference across resistor. If you go back and you check, you will see there is a one resistor and here was written Vout, mean this is the potential difference across this resistor. In the previous part, we have already discussed that when V in greater than 1.0 volt, a Vout was simply positive and this was equal to plus 5 volts. And when V in this was less than 1.0 volt, our Vout was means the output of op amp that was negative, and this because the diode was connected in reverse biased. Diode was connected in reverse biased, so this Vout this was equal to 0 volt. Now these concept, these points we simply need to use and we need to sketch the graph. So let me show you how to sketch this graph. As you can see here now, I have already sketched this one for you. So you can see here at this point, let me highlight some points so you can see what is happening. So you can see here at this point from here to here, the V in, so this V in, this is greater than 1.0 volt. So you can see over V out, this is positive and this is equal to 5 volts. And if you look at these 2 points, in this case V in this is less than 1.0 volt and our output is 0 volt, as you can see here. And again you can see between this point and this point, V in is again greater than 1.0 volt and our output is 5 volts, as you can see it, and so on. Now let's move on to second part now. Just a use for this type of circuit. You can see here with this type of circuit we can reshape, actually we can reshape our signal. You can see this signal was given and with the help of this circuit we have reshaped this circuit. So we can simply say we can use this circuit as a regenerator amplifier. So here is answer for second part. So simply you can say we can use this kind of circuit as a regenerator. That's all for today's class, and I hope that you have better understanding about operational amplifier.